In February 2020, an object named 2020 CD3 was discovered by the Catalina Sky Survey, an endeavor funded by NASA aiming to study the things closest to planet Earth, near-Earth objects. CD3 is one such object, an especially rare lump of rock about the size of a car orbiting Earth at a distance of 48,000 miles at its closest. The scientists who announced its discovery, Theodore Pruin and Kacper Virchos, think it could have been in Earth's orbit for around 2 to 3 years, though the data is so fresh that we don't have an exact time frame just yet. Building one requires retroactively studying the trajectory of CD3 all the way back to when it was first captured by Earth. But all good or unexpected things must come to an end, and no sooner has it arrived, is CD3 predicted to be ejected from Earth's orbit sometime in April 2020, after which it'll get back to what it was doing before it crossed our path, orbiting the Sun. Because it's only here for a short while, this small asteroid is what's known as a temporarily captured object, or TCO. It was snared by Earth's gravity during a particularly close flyby, at a minimum distance of 1.6 million miles according to NASA's Jet Propulsion Laboratory. Simply put, CD3 just so happened to be orbiting the Sun at roughly the same distance as Earth at a particular point, meaning that it got too close to us and was pulled in for a short while. Though an asteroid no bigger than a car might not seem especially exciting, TCOs are actually quite rare, and what's even rarer is scientists spotting one before it takes off again. The first TCO was discovered in 2006, called 2006 RH120, and was also found by the Catalina Sky Survey. Just like 2020 CD3, this was a small rock that was ultimately ejected, but it left an impression. Even today, debates continue about whether it was a true TCO or a piece of space debris left over from an Apollo mission. Since it's long gone, we may never know for sure whether RH120 was a piece of trash or something more intriguing, but we might yet have enough time with CD3 to learn invaluable things about these objects. Though we've only ever formally identified 2 of them, some astronomers think that there could feasibly be one so-called mini-moon orbiting the Earth at any given time, meaning that CD3 is soon to be replaced by another object, if there isn't already another one hiding away up there. The reason TCOs are still so rare, however, is really a matter of mathematics. To become a TCO, an object has to enter Earth's orbit at such a precise angle and velocity that they escape either of the 2 much more probable fates, that they fall to the surface and burn up, or that they're flung back out into space in a completely new direction. TCOs approach Earth in just the right way that they're caught up in its orbit to literally hang around for a while. Which is all well and good, but what's the source of these things? Most likely, a TCO around Earth just wandered out a bit too far from the asteroid belt between Mars and Jupiter, and then had its path around the Sun briefly interrupted, by us. One object just like this is 2016 HO3, discovered just 4 years ago, although it's been around for centuries. 2016 HO3 is not a captured object. It just happens to orbit the Sun at roughly the same distance and speed as Earth, meaning it effectively follows us around the solar system. As ominous as that sounds, it'll probably continue to do so for a few hundred years more until eventually drifting away. But while the thought of suddenly gaining a brand new moon is novel to us here on Earth, multiple satellites are far from a rare occurrence elsewhere in the solar system, and the number of moons a planet has actually has little to do with its gravity or size. Though it's true that Earth's moon is the largest moon of all, relative to the size of the planet it orbits, other planets have many more. Jupiter has a huge 79 moons, and counting, while Mars, smaller than Earth and with a weaker gravity, has 2, Phobos and Deimos. Even Pluto, famously downgraded to a dwarf planet in 2006, actually has 5 moons of its own. But despite being the closest celestial body to us, our own moon remains an incredibly mysterious prospect. We can't even agree on how it got there. The most popular theory to explain the origins of the moon is the giant impact hypothesis, which says that another body crashed into the early proto-Earth at the dawn of the solar system. This object was so huge that it knocked out enough debris to eventually accumulate together and form the moon. According to the earliest theories, the other body in question may have been an entire planet called Theia, and there is some science to back that idea up. Chemically speaking, the Earth and Moon are incredibly similar. They have nearly identical oxygen isotope and titanium isotope ratios, which lends weight to the idea that the Moon was once part of the Earth. But strangely enough, this same evidence could also disprove the theory, since the Moon is so similar to Earth that we don't see signs that any pieces of it once belonged to another planet or object. This means that if Theia did exist and crashed into Earth, little debris from it could have gone on to form the Moon. So what happened to Theia remains the great unknown. But there is another theory. the capture theory. It proposes that the moon was simply pulled in by Earth's gravity fully formed and has stayed there to this day, just like the CD3 mini-moon, only on a much larger scale. Though this theory relies on some assumptions that have since been disproven, namely that the Earth and Moon should be totally chemically alien to each other, which we now know they're not, it could be technically possible for Earth's gravity to snare an object so large. And the capture theory does better explain things like why the Moon is tidally locked. Elsewhere, there are even some cosmic models that say there were originally two moons in the sky, and that they crashed into each other to form one, which may explain why the near and far sides of the Moon are so different. Say a new celestial object the size of the Moon came careening towards us today, though, then a collision would be the most likely outcome. If the giant impact hypothesis is correct for the Moon we already have, then the Earth and new Moon in this scenario should ultimately recover to strike a harmonious balance, but it would again take billions of years. And needless to say, at the hypothetical time of impact, we'd see massive apocalyptic changes all over the world. And even if a large enough second moon didn't crash into us, but orbited us instead, it would likely still cause devastating floods and weather patterns all across Earth. We're lucky then that temporarily captured objects like 2020 CD3 are so small, and also that there's so much nothingness between Earth and the Moon, and TCOs. On average, the Moon is 238,000 miles away from us, so even with small asteroids getting pulled in every now and then, there's little to no danger of cataclysmic meteor strikes or the onset of Armageddon. Even when we're studying at relatively close quarters, there's plenty of empty space to fit everything in. If we were to attract a bigger moon, there could well be trouble, or if two moons were to collide in Earth's orbit, we could feel the consequences. But as it is, something like 2020 CD3 is an object to get excited about rather than be frightened of. We may have a much weaker gravity than the Sun, but every so often a small object draws close enough to join us on our journey around the solar system. And that's why Earth, in 2020,